Hi, I'm Ming, and this is Kitchen Matters. We're a team of material science grad students helping you explore the science of food. Today, Ethan is joining us with a cooking conundrum.
Hi Ming. So there's a question that's been on my mind recently. I use a combination of oil and butter in my cooking, and I know that they're both sources of fats. But oil is a runny liquid, while butter is a solid block. So what exactly are fats, and what makes oil and butter different from each other?
Yeah, that's a great question. Our diet is full of fatty foods, including dairy products such as cheese and butter, meats and fish, as well as our favorite, chocolate. But what exactly do we mean when we say the word fat? Before we move on, it may be helpful to review your knowledge of phase transitions by watching one of our earlier videos. Now, all of these fatty foods that we discussed are made of molecules called fatty acids. There are many different kinds of fatty acids, and different types of fatty acids will give food different textures and properties. All fatty acids have the same basic structure. They're all chains of carbon atoms, generally with 2 hydrogen atoms attached to each carbon. You can see that at the tip of each fatty acid is a collection of atoms called a carboxylic acid, hence why these molecules are called fatty acids. Fatty acids can differ from one another in important ways. For example, some fatty acid molecules are long, and others are short. Fatty acids can also differ in how the carbon atoms within them are connected. You see, carbon atoms can be connected to each other by single bonds or by double bonds. In some fatty acid molecules, every single carbon atom is connected to its neighbors by single bonds, and these are called saturated fatty acids. Other fatty acids contain a mixture of single and double bonds between their carbon atoms, and these are called unsaturated fatty acids. Notice that it's almost as though the unsaturated fatty acids have additional spaces where hydrogen atoms could go. That's why they're called unsaturated, because they have room for more hydrogen atoms. In addition, observe that in these unsaturated fatty acid molecules that the double bonds introduce bends in the molecular structure.
Well, that's very interesting, but why does it matter that some molecules are bent and other molecules are straight? What does that have to do with any of the food in my kitchen?
One of the consequences is that saturated and unsaturated fatty acids will have very different melting points. Imagine we have two foods, one that's made of saturated fatty acids and one that's made of unsaturated fatty acids. Based on your knowledge of phase transitions, which food do you think will have a higher melting point? The one with saturated fatty acids, the one with unsaturated fatty acids, or will they have the same melting point? Let's think back to how melting works. Remember, the molecules of a material are held together by these intermolecular forces, which you can think of as being like weak bonds that attract each molecule to its neighbors. To melt a material, we need to supply enough heat to overpower these intermolecular forces and separate the molecules from each other. First, let's think about saturated fatty acids. Saturated fatty acids are generally pretty straight chains, and you can see that the fatty acid molecules pack quite well together. In comparison, unsaturated fatty acids are bent, and the molecules don't pack as nicely together. Therefore, since saturated fatty acid molecules pack more tightly together, you need more energy to separate those molecules from each other. That means saturated fatty acids have higher melting points than unsaturated fatty acids. Let me re-emphasize here that the key determinant of the melting point is how much energy you need to overcome the forces between the molecules to pull them apart. We aren't changing anything about the molecules themselves. Each individual fatty acid molecule stays the same, but we're simply pulling them apart from their neighbors. That's a pretty subtle point, and honestly, it took me a while too to understand this when I first learned about this.
Oh, okay. So foods with saturated fats have a higher melting point because the molecules are packed more tightly together. Does this relate to my original question about oil and butter?
Everything we just discussed actually helps to explain why oils are liquid at room temperature, whereas butter is solid. Butter is primarily composed of saturated fats. Therefore, butter has a pretty high melting point. Room temperature is below the melting point of butter. Therefore, butter is solid at room temperature. In contrast, many oils are primarily made of unsaturated fats. Therefore, oils have a lower melting point and are generally liquid at room temperature. In reality, commercial food products usually contain a mixture of saturated and unsaturated fats. For example, let's compare two different oil products, coconut oil and olive oil, which contain different percentages of saturated and unsaturated fats. Which of these oils would you expect to have a higher melting point, and why? That's right, the answer is the first one. Coconut oil has more saturated fats, and therefore the molecules are packed more tightly together, making it harder to melt. Of course, the amount of saturated and unsaturated fat isn't the only thing that affects melting point, but it is a big factor, and in the next few videos we'll discuss other factors that govern the melting point. Finally, we should note that in most foods, fatty acid molecules don't exist in isolation. Instead, fatty acids are usually grouped together into larger molecules called triglycerides. Usually, 3 fatty acids are grouped together by a glycerol molecule, and this resultant larger molecule is called a triglyceride. In most books, you'll see triglycerides drawn like what I've made here, where the molecule kind of looks like a capital letter E. But in reality, many triglycerides actually look like this, where the middle fatty acid is pointed in the opposite direction. This makes the molecule a little less crowded, and we'll discuss this structure more in future videos about chocolate. You can have triglycerides containing saturated fatty acids, unsaturated fatty acids, or a combination of the two. So, what did we learn in this video? Fatty foods are made of fatty acids, which can be saturated or unsaturated. Second, saturated fatty acids generally have higher melting points because the molecules can pack more tightly together. And finally, in foods, fatty acids usually don't exist in isolation. Instead, fatty acid molecules are grouped together into larger molecules called triglycerides. Alright, now that you understand the fundamentals of fat, in the next few videos we'll take a deeper dive into chocolate and uncover the mysteries of cocoa butter, the main fatty component of chocolate. See you then.